Good morning. My name is Partho Majumdar. I am speaking to you from Bengaluru or Bangalore as it was known earlier in India. It is good morning because it's about 3:10 in India right now in the morning. I thought of recording this video as it could be useful for many people. It's about arithmetics done in a Vedic way. Now, arithmetics you may associate with subject for children, but however, the techniques I'm going to discuss can be of interest for adults as well. More importantly, I found that this could be of interest for computer programmers because the methods which I'm going to discuss can make computer programs much more efficient. So let's discuss digit sums and see its properties. I will explain the concept of digit sums on whiteboard first before I take it to computer programs. Digit sums is very simple. It is actually the sum of all the digits in a number. So let's take a number. Let's say it is 2, 4, 3, 7, 1, 8, 9, 0, 2. So it's a very large number. Digit sum is nothing but if you add all the digits together. So if I add these digits together, if I put a plus in between each of them and I find the sum, that is the digit sum. So we will see how to find that. So let me just put the symbols just for completeness. So now we have this. So 2 plus 4 is 6, 6 plus 3 is 9, 9 plus 7 is 16, 16 plus 1 is 17, 17 plus 8 is 25, 25 plus 9 is 34, 34 plus 0 is 34, 34 plus 2 is 36. So we get 36. Now this is a two-digit number. So we further add the digits together. So I add 3 plus 6 and I get a 9. So now this number's digit sum happens to be 9. So you may say that this is daunting because you have to add so many numbers, and if the number is large then it can be very daunting. But that is not the case because digit sum has some properties where we can utilize to minimize the calculations. The first property is that, of course, you can eliminate all the zeros because zeros have no value on the sum. So you can eliminate that. Further, you can eliminate the nines because we will see soon the 9 has got a special property because of which we can eliminate the nines. So now let's do the digit sum once again without the 9 and see what happens. So we have 2 plus 4, 6, 6 plus 3, 9, 9 plus 7, 16, 17, 17 plus 25, 25 plus 2, 27. So I get 27. So if I add 2 plus 7, I again get a 9. So you see the digit sum does not change if I remove the 9s. We can further simplify this. Now look for combination of numbers which add up to 9. So for example, this 2 plus 7 makes a 9. So I can eliminate that. Similarly, 1 plus 8 makes a 9. So I can eliminate that also. So now let's find the digit sum once again. It's 4 plus 3, 7, 7 plus 2, 9. Actually, you may say that 4 plus 3, 7, 7 plus 2, 9, I should have eliminated that. So if you have left with nothing after eliminating the digits, then you should not eliminate them. You should just retain them and calculate the digit sum. So you see, it is so simple to find the digit sum, which is always coming out to be 9. So what we discussed was that you add all the numbers to find the digit sum. If it is a two-digit number, add them together and get the digit sum. So next we discussed that we can eliminate the zeros and nines, and also we can eliminate the combination of digits which form a 9 to find the digit sum. So let's just try on another number. Let's say 1, 7, 2, 3. So this is the number. So by raw method, it is 1 plus 7, 8, 8 plus 2, 10, 10 plus 3, 13. And 1 plus 3 is 4. Now we know that we can eliminate some digits which sum up to 9. So I can eliminate 7 and 2. And so I get 1 plus 3, which is also 4. So this is the mechanism to find digit sum. Now what happens is that the digit sum always is a number which is between 1 and 9. Any number's digit sum will always be a number which will be between 1 and 9. Now this is a special property of the number 9. So based on this property, Vedic math says that I can draw a circle of 9. So if I draw a circle and I plant 1 to 9 on this, so I say 1, 2, 3, 4, 5, 6, 7, 8, and 9. So when I have this, so we in decimal system we have a circle of 10 numbers 0 to 9, but for digit sums we have a circle of 9. So now you see that if you add 9 to any number, let's say I add 9 to 1, I will get 10. Now 10 also has a digit sum which is equal to 1. 1 has a digit sum which is equal to 1. 10 also has a digit sum which is equal to 1 because 1 plus 0 is 1. Further, if I add 9 to 10, I get 19. 19 again has a digit sum of 1 because 9 plus 1 is 10 and 10 means 1 plus 0 is 1. Let's try one more. 19 plus 9 is 28. You see that 8 plus 2 is 10. So 10 means 1 plus 0 which is 1. I can do it for any other number, let's say 4. 4 plus 9 is 13. 13 means 3 plus 1, again digit sum is 4. So 13 plus 9 is 22. So you see that 22 means 2 plus 2, 4, and 4 is the digit sum of 22. So all the numbers on this axis will have a digit sum of 4. Similarly, all the numbers on this axis will have a digit sum of 3 and so on. Now, digit sum has got some other properties as well. The thing is that if the digit sum of a number is 3 or 6 or 9, then the number is divisible by 3. Number is divisible by 3. So let's prove it. Let's take a number, let's say 81. Now 81, I know the digit sum is 9, and if I divide 81 by 3, I get this is equal to 27. Because you see 3, this goes 2 times, it goes 2 times 3 is 6 and remainder is 2. And 2 times 7 is 21. So digit sum 81 by 3 is 21. I need not do so much, because if I just find the digit sum and I see that the digit sum is 3, 6 or 9, I know that the number is divisible by 3. I can try one other also. Let me say 144. The digit sum is 9, and if I divide this number by 3, I get 4 times 3 is 12, so I get a remainder of 2, and 3 times 8 is, so 144 by 3 is 48, which is, so I can see that 144 is divisible by 3. Now let's take a number 154. Now let us see what is the digit sum and see. So I know that 54 means I can eliminate 5 and 4 because this sum up to 9, so the digit sum is 1. So this number should not be divisible by 3. So if I try to divide this number by 3, I get 51 and remainder 1. So this number is not divisible by 3. Okay, so this is the first property. Second property is that if the digit sum is 9, then the number is divisible by 9. So if the digit sum happens to be 9, then the number is divisible by 9. We can just quickly verify this from this example itself. Here 81's digit sum was 9, so we know that 81 by 9 is equal to 9. So we can see that this is divisible by 9. Similarly, we can see also from this example, because it so happened that the digit sum came out to be 9 for a number chosen at random. So if I divide 144 by 9, I get, this is 1 and 6, 16. This is 1 time and remainder is 5. So 6 times 5, 9 is 54. So this is also divisible by 9. Now you can check on this number whose digit sum is not 9. So if I try to divide this number by 9, I will get 1 times 9 is 9. So I get a remainder of 66. So 7 times 9 is 63. So I will get 1 by 9, 17, 1 by 9. So you see that these two properties we have now established, that if the digit sum is 3, 6 or 9, the number is divisible by 3. If the digit sum is equal to 9, the number is divisible by 9. Now let's go to the next property. Now digit sums can be utilized to verify addition, multiplication, division and subtraction. Let's see an example. Supposing I have two numbers, 235 and I have another number 563. So if I add these numbers, so 5 plus 2, 7, 6 plus 3, 9 and 5 plus 3, 8. So now I want to know whether the addition is correct or not. So instead of trying to do addition like this, what I can do is that I can find the digit sums. So the digit sum of 235 is 5 plus 5, 10. 10 means it is 1. 1 plus 0 is 1. The digit sum of this number is, I can eliminate 6 and 3 because this add up to 9. This is equal to 5. And the digit sum of this number I can find, that is I can eliminate 9. 8 plus 7 is 15. 15 means 5 plus 1. Digit sum is 6. Now if you add the digit sums, if they are adding properly, that means the addition is correct. So you can see that 5 plus 1 is 6. So the addition is correct. I can take another example for you. Let's say 5, 9, 4, 3 plus 2, 7, 3, 8. So if I add these two numbers, so I get 5 plus 2, 7, and the next number I see that there is going to be a carry, so I add 7 plus 1, 8 here. So 9 plus 7 is 16. I have already taken the carry in the forward. The next digit does not have a carry, so I can just put 6 here. And 4 plus 3 is 7. The next digit has a carry, so I will just 7 plus 1, 8. And 8 plus 3 is 11, so I just put the 1. So you may now want to verify whether this is correct or not. So let's do that. So I can eliminate 9. I can eliminate 5 plus 4. So digit sum is equal to 3. And here I can eliminate 7 plus 2. So this is 9. So I'm left with 3 plus 8. That is equal to 11. So digit sum is 1 plus 1, 2. Now here I can eliminate 8 and 1 because this is 9. Now I see 8 plus 6 is 14. 14 means 1 plus 4, which is equal to 5. So you see that the digit sums of 3 plus 2 is equal to 5. So this addition is correct. So this is a mechanism to verify whether your addition is correct or not. Many times when you have to quickly add mentally, you can verify whether your arithmetic is correct or not by using digit sums. Now since I can do addition, it also applies to subtraction. So if I subtract a number, let's say 9, 5, 4, 3, 6 minus, this was addition, minus 7, 2, 6, 3, 5. So I can do the subtraction. 9 minus 7 is 2 and 5 minus 2 is 3. I have to take a carry from here. So this 3 becomes 2 and I put a 1 here. 14 minus 6 is 8. 3 minus 3 is 0. 6 minus 5 is 1. So let us see whether I did correctly or not. So let's find the digit sum. So 9 goes, 5 plus 4 goes, 6 plus 3 remains. The digit sum is equal to 9. So here 7 plus 2 goes, 6 plus 3 goes. So this is equal to 5. and here I get 8 plus 1 equals to 9. So I'm left with 4. So now since 9 minus 5 is equal to 4, this subtraction which I have done is also correct. So I can apply this to multiplication as well. So supposing I have a number 61 multiplied by 23. 61 multiplied by 23. So now let me find this for you. So let's do it in the conventional way, not in the Vedic way. So this is equal to 3, this is equal to 18, and this is equal to 2, and this is equal to 12. This is not the way Vedic people would do the multiplication, but nevertheless I'm keeping it in the conventional manner right now. 8 plus 2 is 10, 3 plus 1, 4, and 1. So now let's verify whether this multiplication was done correctly or not. So this is 6 plus 1, 7, 2 plus 3, 5. Now if I multiply these two numbers, I get 35. 35 means the digit sum is equal to 5 plus 3, which is equal to 8. And here let's verify. 1 plus 4 is 5, 5 plus 3 is 8. So now you see that this digit sum and this digit sum is matching. So my multiplication, what I have done, is correct. The same thing can be applied to division as well. So you see that the digit sum has got a number of properties which can be exploited and which can make maths much less complicated for you. Now having seen this, now let's next go on to using digit sums in writing computer programs. So here I have given you a computer program which calculates the digit sums. I will briefly explain this because many people may not be interested in computer programs, but if you are from here onwards we will be discussing some computer programs, so if you are not interested you can switch off. Nevertheless, this is a function which can calculate the digit sums. So what it does is that it finds out if the number is greater than 0, and if it finds the last digit, and it appends the digits one by one, and it makes a list. Now in this list, it will first eliminate all the zeros. So this portion it eliminates the zeros in the number, and after that we eliminate all the nines in the number unless there is only one 9 left in the number. Then what we do is that this part of the program, it removes all the digit combinations which add up to 9. The combinations can be 2 digits, 3 digits, 4 digits, etc. And it continues to eliminate till there is only a combination of 9 or some digits which combine up to 9. That is all remaining. So this program does that, and then it finds the digit sum. And this program is called recursively, so that if in case I get a digit sum which is more than one digit, I can redo this logic to find the digit sum once again. So this function can calculate the digit sum. Now this function can be made more powerful and more strategic by adding parallel programming. So this is a function where the digit sum is calculated parallelly. So this is very useful in case you are dealing with very large numbers. So the people who understand Python programming will definitely understand this. So I did not deal with that too much. Now let's go to seeing how we can make the calculations of divisibility much more efficient. First, let's discuss the divisibility by 2. Now you see that a number is divisible by 2 if the last digit of the number is 0, 2, 4, 6 or 8. So I need not actually divide the entire number. Instead, I can just find the last digit. If the last digit is 0, 2, 4 or 6 or 8, the number is divisible by 2. Next, we see the divisibility by 3. So we've already discussed this. What I have to do is that find the digit sum. If the digit sum is 3, 6 or 9, the number is divisible by 3. Let's check the divisibility by 4. Divisibility by 4 is that if the last two digits of the number is divisible by 4, I can say that the number is divisible by 4. So I can find the last two digits of the number by simply dividing by 100, and I get I take the last two digits or remainder by doing a mod operation, I will get the last two digits, and if I see the last two digits are divisible by 4, the number is divisible by 4. Divisibility by 5 is very simple. I just find the last digit, and the last digit, if it is 0 or 5, it is divisible by 5. Now comes the trick. Now, to find divisibility by 6, all I have to do is that 6 is equal to 2 into 3. So if a number has to be divisible by 6, it has to be divisible by 2, it has to be divisible by 3. So I first check whether the number is divisible by 2. That is, I check whether the last digit is 0, 2, 4, 6 or 8. And if it is, then I check if the number is divisible by 3 by finding the digit sum and checking whether the digit sum is equal to 3, 6 or 9. So it can make checking divisibility by 6 so simple. Next, we check the divisibility by 8. Divisibility by 8 is very simple because I have to find the last 3 digits, and if the last 3 digits of the number is divisible by 8, the number is divisible by 8. We already discussed this about divisibility by 9. So I find the digit sum. If the digit sum is equal to 9, the number is divisible by 9. Divisibility by 10 is very simple because if the last digit is equal to 0, the number is divisible by 10. Now see that I can combine all this knowledge that we have gathered right now to find divisibility by very large numbers. Supposing we want to find divisibility by 450. So all I do is that check that 450 equals to 10 into 5 into 9. I wrote it in this order because finding divisibility by 10 and 5 are much simpler as compared to finding divisibility by 9. So I first find whether the number is divisible by 10. If it is, I check whether it's divisible by 5. If it is, I check if it's divisible by 9. If it is divisible by all the three numbers, the number is divisible by 450. So I hope you found this video of interest. Please write your feedback and I will be more than glad to hear from you. Thank you so much.